Hey everyone, my name is Fons Jacobs, and welcome back to another episode on the Band of Insiders podcast. It's a new week, so it's time for another feature episode. In the feature episodes, I am going to dive deeply into some of the most exciting and interesting topics when it comes to innovation, new technologies and trends, and everything that's going on in the world around it. During these feature episodes, I'm going to try to explain technology as easy as possible, making it understandable for everyone who's watching or listening. Added to that, I'm going to share my opinions, ideas I have about the future, and where things should go. So without further ado, let's jump into this week's feature episode, and I hope you enjoy it. Google has been on an absolute massive winning streak the last few weeks. A great reason to dive in a bit deeper into how they got here. A fascinating road of the right acquisitions, long-term visions, and bumpy starts. Let's start at the very beginning. Google began as a Stanford project in 1996 when Larry Page and Sergey Brin built Backrub, an indexing bot that scanned the web and ranked pages with a new algorithm called PageRank. They registered Google.com in September of 1997 and incorporated in September of 1998. After receiving a $100,000 check from Sun Microsystems co-founder Andy Bechtolsheim. Then they set up in Susan Wojcicki's Menlo Park garage. Interestingly enough, Susan was employee number 16 of Google and later became longtime YouTube CEO before passing from cancer in 2025. From day one, the mission stayed the same and still guides the AI push today. Organize the world's information and make it universally accessible and useful. We all know that Google didn't remain just a search engine, although their product alone truly revolutionized the way we use the web. For the first time, you could use one website to find other websites, instead of directly typing in a specific www. The word Google it or Googled it became a verb, and interestingly enough, it is also a verb that once again will disappear, as I don't think that kids growing up now will ever really use it in the future. In order for Google to become the AI giant that it is now, let's look at some critically important moments and decisions they made, leading up to maybe the most important one, which was the acquisition of DeepMind. I'll now list some of the most important acquisitions and tools that they have in their toolbox today. First off, Ad Engine and Measurement AdWords launched in 2000, AdSense in 2003, Google Analytics through Erkin in 2005. DoubleClick was acquired in 2008. Altogether, a cash machine, real-time demand insights, and deep ties with brands and agencies. Then 2006, the massive acquisition of YouTube, the world's video attention and creator economy under one roof. Then Android, acquired in 2005, and the first phones were launched in 2008. They now had a default presence on billions of devices and a direct path to ship new features. Google Chrome was launched in 2008, a desktop control point where one browser update can change user experiences at scale. Knowledge Graph launched in 2012, but MetaWeb was also acquired in 2010. A structured catalog of people, places, and things that improves result quality and keeps users in the Google experience. Then there was Maps and Waze. Google Maps launched in 2005 and Waze was acquired in 2013. Another big advantage, their daily use utility with local businesses ties and high switching cost. Gmail and Workspace. Gmail launched in 2004, Google Apps for your domain in 2006, rebranded to G Suite in 2016, rebranded to Google Workspace in 2020, recurring enterprise footprint and a trusted channel to roll out new capabilities. Google Cloud, a key early pillars, App Engine in 2008, BigQuery in 2011, Compute Engine GA in 2013, enterprise relationships, and infrastructure revenue that pair well with the rest of the stack. Google Stack deals, products, and launches that plugged into everyday life. Ads and analytics captured what people wanted. YouTube captured what people watched. Android and Chrome became the new doorway on phone and desktop. Maps and Waze mapped how people move. Gmail and Workspace anchored how teams communicate, and the Knowledge Graph organized the world's facts. Layer cloud on top, and you get the pipes into enterprise data as well. The result is a company fully wired into the moments people work, watch, move, and buy with a steady flow of real-world signals at global scale. For more than a decade, that breadth and depth has given Google arguably the densest feed of intent and behavior on the internet. Plus the distribution to turn those insights into products quickly. Why does this data matter for AI? All those touchpoints create three things AI needs most: range and variety of data, freshness and context. Range and variety of data comes with the wide range of moments Google sits in, from search and video to maps and mail. Freshness comes from products people use daily, which turns user behavior into a constant feedback loop. Context comes from seeing actions across devices and sessions, which helps systems interpret intent rather than just match keywords. The effect is simple: better signals in, better results out. In practice, this data powers training, so systems learn the patterns of language, media, and behavior; tuning, so results feel helpful for specific products and use cases; and evaluation, so teams see quickly what works and what falls short; and then last but not least, personalization and safety, so experiences adapt to the users while filtering spam and abuse. Put together, Google has arguably the richest mix of signals on the internet, plus the distribution to roll out improvements and products out fast. Now let's switch to AI. Google Brain. It was Google's first true AI team in the modern sense, led by Jeff Dean, Greg Corrado, and Andrew Ng, to see what very large neural networks could do with Google's data. In 2012, the team ran a now famous experiment where a huge system was trained on YouTube frames and learned to spot patterns like cats without any labels. It proved that skill changes the game. The Atlantic shared an article in 2012 covering the AI breakthrough with the title, "The Triumph of Artificial Intelligence. 16,000 processors can identify a cat in a YouTube video. Sometimes." Damn, we've come a long way. That same year in Toronto, Geoffrey Hinton's group with Alex Krzyzewski and Ilya Sutskever won a major photo recognition competition by a wide margin. It was the moment the industry noticed this approach could leap ahead. In 2013, Geoffrey Hinton, often called the godfather of AI, joined Google through the DNN Research acquisition and helped spread deep learning know-how across teams. Google Brain moved from side project to core research engine, setting up the path to TensorFlow and soon after, Google's custom AI chips. With Google Brain established and Hinton on board, Google had a working AI engine inside the company. The next step was to add a second one, called DeepMind. DeepMind began in London in 2010, founded by Demis Hassabis, Shane Legg, and Mustafa Suleyman, now CEO of Microsoft AI actually. With a bold ambition from day one, build a general-purpose learning system on the path to AGI. They say, solve intelligence, then use that to solve everything else. Google acquired the company in early 2014 for a reported sum just over $500 million. As part of the acquisition, DeepMind's founders insisted on a joint Google DeepMind ethics board to oversee sensitive projects such as AGI, aka Artificial General Intelligence. The first major breakthrough happened pretty fast after, introducing AlphaGo. DeepMind decided to build a model to play the board game Go because it was the hardest classic board game for computers. The game's branching factor is huge and positions are hard to judge, so the brute force tricks that worked in chess do not scale. They say there are more Go moves possible than there are atoms in the universe. If you can make a system plan well in Go, you probably have something general enough to matter beyond games. This was the thinking behind why they wanted to try and build this model. Their AlphaGo approach started simple. First learn from thousands of expert human games to get a feel for good moves, then improved by playing itself over and over. While a second network learned to estimate who was likely winning from any position. During play, it used this intuition plus look-ahead combo to explore only the most promising lines rather than everything. To test it, they begin privately. In October 2015, AlphaGo beat Europe's champion Van Hooy 5-0 in a close match at DeepMind's London office. Fan then worked closely with the team, advising and training in their office as AlphaGo was strengthened for the bigger stage. That stage was set for Lee Sedol, a 9-dan legend nicknamed the Strong Stone. Lee ranked second in all-time international titles, with 18 as of early 2016, and was widely seen as the defining player of the 2000s. Many expected him to win comfortably, and Lee himself predicted a 5-0 or 4-1 result in his favor. I truly invite you to watch the documentary to see what happened. It is a phenomenal thing to watch, and is completely free on YouTube. But for the people who will not watch it, I'll explain what happened in short. In March 2016, Four Seasons Seoul was the stage. The room was pin-drop quiet as AlphaGo faced Lee Sedol. Game 1 set the tone. Lee, playing in black, played a cold steady game, but AlphaGo, playing white, pulled ahead late, and Lee resigned. Afterward, Lee said he'd made an early mistake and that AlphaGo's early strategy was excellent, including an unusual move no human would likely choose. Then there was Game 2, and then there was Move 37. A play so unexpected that commentators called it a blunder, and Lee stepped away from the board before returning with a long, careful reply. It turned out to be brilliant. AlphaGo's calm, whole board control built a 3-0 lead. Lee answered with his own flash of genius in Games 4 God Move 78, but AlphaGo closed the series 4-1. The ripple effects were immediate. Go pros rewrote their game playbooks. The AlphaGo documentary brought the story to a global audience, and policymakers treated it as a before and after moment for AI. Move 37 showed us something very particular and very interesting though. DeepMind said a human would pick that move roughly 1 in 10,000 times. It showed the system wasn't just copying human play or brute forcing lines. AlphaGo combined learned instinct with selective look ahead to find a line pros had overlooked, then converted the idea into a win. That moment proved AI could generate original, high-level strategy and not just mimic databases. A question that gets asked a lot with regards to AI is, can it create something new, or will it just always copy another thing? The answer might lie in Move 37. So from the start, Google was focused on the long horizon bet, build general purpose AI, which is why bringing DeepMind into the fold in 2014 made so much sense. Then, GPT 3.5 landed through OpenAI in late 2022, and the public reaction and success moved faster than anyone expected. Sundar Pichai later said the generative AI boom took Google by surprise. Google triggered a company-wide code red, reassigning teams and accelerating product plans, even as leaders like Jeff Dean reminded staff the company had held back similar chatbots over reputational risk in 2022. It was clear though that they had to pivot. When the 2002 AI hype train started, I had always believed that Google was the clear favorite to build the best AI possible. Again, considering all that they have and all that they already achieved. But damn, what a rocky start it was. In February 2023, Google demoed its new chatbot, Bart, and it kinda sucked. Wiping $100 billion off of Alphabet stock price in a day after a promotional video had an incorrect answer from Bart in the video. A year later, Google rebranded Bart to Gemini. I guess for a fresh start? This all went sideways again when it had to pause its image generator for people after historically inaccurate outputs like diverse, Nazis, and Vikings. It was clear that Google was caught off guard by the impact of Gen AI and was playing catch-up. I kinda thought this might even would cause Sundar Pichai to be fired, as the backlash from Google was enormous. Fast forward 2 years, and the opposite is true. Sundar has shown incredible resilience, and many of his decisions have proven to be the right ones. Sundar Pichai collapsed the split system into one unit, called Google DeepMind, in April 2023, put Demis Hassabis in charge, and moved Jeff Dean into a company-wide chief scientist role. The new group kept research stars, but added clearer product ownership. Koray Kavuchoglu leading research, Eli Collins running product, and the scientific board to steer priorities. The mandate was simple: one roadmap, faster decisions, and tighter handoffs from lab to product. The direction showed up fast in the Gemini era. Google framed Gemini 1.0 in December 2023 as the first realization of the newly unified team. Then they pushed 1.5 with a breakthrough-long context window 2 months later. An early strategic decision now seems to be bringing a lot of success to the Google team. Gemini would be multi-model from day one. One family of models built in different sizes, all wired back into the same spine. Search, Workspace, Android, YouTube, every surface would run on Gemini. That choice now seems to pay off. We can see that now with VO3, embedded in Gemini, and Vertex AI, generates video with realistic motion, physics, and synchronized audio. Then there's Genie 3. It acts as a world model, producing playable environments in real time, a glimpse of interactive media's future. And of course, Gemini 2.5 Flash Image, aka Nano Banana, delivers quick, consistent image generation and editing inside AI Studio. Three products, three different domains, all drawing strength from the same Gemini backbone. The effect is clear. Instead of scattered experiments, Google ships a coordinated wave of models that improve together. This is also where Google's approach differs from OpenAI's, as they took a different route. GPT-3 and 3.5 were text-only. GPT-4 added vision, and true real-time multimodality only arrived when GPT-4o in 2024. But how multimodal came together is not the same as how it works for Gemini. For images, they use DALL-E. For speech, they use Whisper. And for video, there's Sora. Separate model families that are gradually being woven together. In other words, Google built one spine, many surfaces, while OpenAI has built many models all stitched together. Both work, but they create very different paths for scale and speed. Now let's look beyond products and look at the big promises of AI. It's easy to get caught up in chatbots, image models, and the product race with OpenAI. But Google, through DeepMind, has also stayed closer to the bigger promise of AI, using these systems to push science forward. The most famous is AlphaFold, which cracked the 50-year protein folding puzzle, released a public database of more than 200 million protein structures, and earned Demis Hassabis, John Jumper, and David Baker the 2024 Nobel Prize in Chemistry. And AlphaFold is just one of many. Over the past few years, DeepMind has delivered a string of scientific breakthroughs that showed what AI can do when pointed at the hardest problems in the world. Let me list a few. AlphaMissen's 2023 predicted the effects of nearly all possible mutations in human DNA, helping researchers pinpoint which genetic changes might cause disease. Weather models from 2021 to 2023. GraphCast produced more accurate medium-range weather forecasts than traditional systems, now used for early warnings on extreme weather. Fusion energy in 2022. Reinforcement learning models trained to stabilize plasma inside nuclear fusion reactors, a step toward viable clean energy. Materials discovery from 2022 to 2023. Identified structures for 2.2 million new crystalline materials, opening pathways to stronger batteries, electronics, and solar cells. And then medical AI, 2016 to 2021. Systems that can spot eye diseases from scans, predict kidney injury hours in advance, and assist radiologists in breast cancer detection. So let me leave you with some closing thoughts. I'll admit it, from the very beginning I thought Google was destined to be the clear winner in this AI race. They had the data, the talent, and the history. That's why their early F-ups, sorry to say, shocked me so much. But the turnaround since then has been nothing short of remarkable. Sundar's call to unify brain and DeepMind, the discipline of building Gemini as a one multi-model spine, and the pace of recent releases have put Google right back at the front. I am in absolute awe of how quickly they've reset the narrative, and I have massive respect for the resilience it took to pull that off inside a company as large as Google. With Gemini 3 rumored to be around the corner, I'll be honest, if it is as good as we hope, I'll probably end my GPT Plus subscription and go all in on Google. The race is heating up. OpenAI was the clear frontrunner for a long time, but Google and xAI, as I wrote about recently, have now officially caught up. The next year will be the most exciting yet. Let's see where it takes us. And that's it for this week's feature. I hope you enjoyed it. Thanks again for watching or listening. And please do subscribe, like, give us some great 5-star reviews, and hopefully I'll see you next time. Thank you.